Dear ladies and gentlemen, let me start my presentation on the topic 3D print problem, protective face shields. For 3D print, I used this 3D printer, German Referat. The printer has a big space of wood platform. It is possible used a lot of different materials, not only ABS, PLA, but it is possible use nylon, carbon, light wood, and so on, because maximum temperature of nozzles are 290 degrees Celsius, and the maximum temperature of heated bed is 120 degrees Celsius. It is possible to change nozzles. For example, it is possible diameter for 0.25 millimeter to 0.8 millimeters, 1 millimeters, and so on. The choice of material depends on the use of the printer object. Each material has different material properties. The carbon printing plate or glass plate is used as a bed for 3D printing. Sometimes I used only glass table, but for print of protective shields, I used carbon bed. And objective of the work are use the printing surface of the 3D printer, optimize 3D printing in terms of compromise between quality and printing speed, and continuous production to reach at minimum 60 shields during 5 days. This was required of Pukov city during COVID time. The protective face shield, according to the standard, consists for 4 parts, and the 3D printer was used to produce the headband. This is upper part of protective shields, and lower part chin. PETG material started to be a critical commodity because a lot of 3D printer owners wanted to provide their help, and this means that not only PETG materials but ABS and the next materials given were sold in an extremely short time. And now I will talk about verification of the correct temperature distribution of the heated bed. And why? Because when 3D printing with PETG material, the temperature must be well setting for obtain high quality products. The optimum heated bed temperature for this material is 80 degrees Celsius plus minus 2 degrees Celsius. And the aim is find the optimal temperature setting of the heating bed to obtain high quality 3D printing of shields. And for verification analysis, I use thermal image camera. And on this picture, you can see situation for setting temperature heating bed to 8 degrees Celsius. But the real situation, if I set 80 degrees Celsius, I obtain only 76 degrees Celsius. The difference between the real and set temperature for the specific 3D printer is up to 4 degrees Celsius, which is a difference of approximately 5%. And on this table, you can see a difference for next temperatures and so on. And based on this value, it is possible to create a graph, dependence between a difference and set temperature for a next research array and so on. And based on the results, the adjusted temperature on the 3D printer for printing the shields is set to 84 degrees Celsius, and the real temperature for this set temperature is only 80.6 degrees Celsius. This is optimum for obtain high quality 3D products. And a second step, I use the same verification analyzing via thermal camera for nozzles. And for nozzles, it's very good because maximum difference was only 2-3 degrees Celsius. And now I will talk about setting of 3D print. The temperature of the nozzle was elected to 244 degrees Celsius for the first layer, and for the next layers I used the temperature 255 degrees Celsius. For printing, I used the nozzle 0.8 millimeters. And for create of G-code, I used Simplify. For next setting, it's one I used Referat host and Referat server with 3D print box computer. And now I will talk about printing time optimization. At first, a total 5 pieces of upper parts headband with 5 pieces of lower parts cheese were printed at once. What does it mean? One shield time was approximately 1 hour and 20 minutes. The time had to be next optimized also for the possibility of a large printing array. As a final, I used 7 pieces of shields at once, 7 pieces of headbands, plus 7 pieces with chains, plus 2 pieces of chains. On these pictures, you can see situation. This is modeling via program Simplify and Referat host. And on this picture, you can see a final real situation on the heated bed plate, which I used special plate, and reduce the printing time for 1 shield to 1 hour and 16 minutes, but the time as final time for prepare 1 shields includes downtime, service working, change nozzles, calibration, verification, prepare G-code, and so on. Altogether 1 hour and 21 minutes. At the same time, efforts were made to minimize crossing outside of the print volume. It's one, what does it mean? For 5 days, we produce 84 pieces. And what does it mean? Per days, 17 shields. And of course, as next way, it is possible play with next optimization time and so on. Minimum maybe 1 hour and only 8 minutes, or 1 hour 5 minutes and so on. But the quality quality decrease. The optimum printing speed is 60 millimeters per second for the specific PETG materials. The material length is approximately for 1 shield, approximately 11.5 meter. I only had half day for optimization, for setting 3D printing, for prepare 3D printer, prepare G-code and so on. Yes. And during printer, it is possible online monitoring because I used infra camera. Not only online monitoring, it is possible because I used special 3D print box. It is possible check 3D printing in online time. It's possible change printing parameters and so on. And on this picture, you can see situation during night. By infra camera. Yes, and on this picture you can see final of the shields and so on. And now I will show you a short video from timer. Okay. As conclusion, the correct temperature distribution of the heated bed was verified using the thermal image camera, and based on the result, the set temperature of heating bed must be to 85 degrees Celsius for the specific PETG material, and the maximum printing speed is 60 millimeters per second. This is as ideal for obtain high quality of face protective shields. And on this picture, you can see final shields, and on the next picture, you can see my colleagues which help me with completion of protective face shields. And nowadays, I prepare new project with the aim produce of filaments for 3D printer with the application of vast material, recycled material, and so on, which use the special equipment protocycle, special machine, and on the right you can see special mixing line machine for obtain filaments from granulate. Next information in future you can find on my website laboratory.sk. Thank you very much for your attention.